If teleporting people ever becomes possible, there'll obviously be concerns about its safety, just as there was about the first cars and planes. In the end, the deciding factor for most people would be the sheer convenience. At first, the cost might be very high because of the enormous amount of data that had to be transferred and the complexity of the equipment needed. Early users are likely to be wealthy and adventurous, future Richard Bransons travelling by tomorrow's equivalent of Concorde. But as the technology became cheaper and people gained confidence in its safety, its use would probably become as routine as catching a bus or making a phone call. With the planet's hydrocarbon reserves low or exhausted, teleportation systems would offer a clean, extraordinarily handy way of crossing distances ranging from a few hundred meters to many thousands of kilometers, and eventually beyond our planet. Providing there's a teleportation facility at both source and destination, and relay stations along the way, there aren't any limits in principle to where people and things might be sent by this means. With a teleportation receiver on Mars, for example, perhaps set up by robot craft, humans could simply beam themselves to that world along with the supplies and materials needed to build a base. Provided the system was kept in good working order, they could be back home on Earth in the time it takes to make a phone call. Future interplanetary explorers might even become daily commuters, an 8-to-4 job mining the asteroid belt, and back in time for dinner. All journeys would be made at the speed of light, a few minutes to Mars, a few hours to the outer solar system, although to the teleported person it would seem like no time at all. Numerous issues will have to be dealt with, particularly on the security front, even if the technical challenges of human teleportation are overcome. The closest analogy we have today is the internet, and the problems that users face on a daily basis. Any global teleportation system would need the equivalent of passwords, secure sites, firewalls, and so forth to prevent people or things from beaming in when and where they're not wanted. Without safeguards, thieves could materialize inside homes in the dead of night, and controlled substances and arms could be shipped around the world without detection. Entire invasion armies could suddenly appear behind enemy lines. In fact, if teleportation of complex objects of any kind begins to loom on the technological horizon, it's quite possible that advanced developments will take place under military wraps. Xenophobic governments might ban the technology to prevent foreigners from freely entering their territories. Worldwide teleportation would quickly make a mockery of customs regulations, border checks, and immigration controls. Its introduction could bring about the final dissolution of national boundaries, but it would also raise the spectre of teleportation hackers, viruses, and spyware, and the havoc these might wreak in a world where virtually all of humanity was continually moving back and forth through the informational domain. Identity theft would take on a whole new meaning. Only quantum teleportation has so far been carried out in the real world, and that's the only kind of teleportation that, according to known science, can create perfect replicas from the subatomic level up. But if we're prepared to relax the rules on how exactly teleported copy has to be, we can envisage a form of teleportation that's more akin to medical scanning. Since this would work outside the pure quantum domain, it would be immune from the so-called no-cloning theorem, so that the original wouldn't need to be destroyed. Call it classical teleportation. It wouldn't be of any use for quantum computing or similar applications that depend critically on quantum effects such as entanglement, but it might be a viable alternative to quantum teleportation for transporting everyday objects, and possibly even people. It all depends how nearly identical the original and copy have to be. Classical teleportation could work in a similar way to the transporters in Star Trek, powerful three-dimensional scanner would analyze the subject on the transporter pad and create a data matrix, a digital blueprint that's temporarily held in a vast computer memory. Almost certainly the power of a quantum computer would be needed to handle the storage and transmission. The subject would then be dismantled, turned into some kind of stream of matter or radiation, beamed to the destination, and put back together on arrival. Classical teleportation might even prove to be more doable than quantum teleportation when it comes to complex macroscopic objects. After all, while we still have no clue how the quantum version would work on anything large and elaborate, medical scanning technology based on MRI, CT and ultrasound already exists and is getting more powerful and sophisticated all the time. The same is true of computers and their memories. Rematerialization might be accomplished by a kind of reverse scanner that, instead of analyzing the atomic makeup, synthesizes it using the blueprint information. This rematerialization process would presumably draw on some aspect of nanotechnology, the technique still in its earliest stages of development today of building things at the atomic and molecular level.